Hey guys, what's up? It's Eric with Advanced Level Automotive. Welcome back to the channel. Today, we're here at another shop checking out this 2007 Cadillac CTS. It's got the V6 3.6 liter engine, and the customer complaint is that the vehicle is having all kinds of electrical issues. The shop took a quick look at it. They decided they really didn't want to mess with it, so they called me out. Now, a few things that they're telling me is that number one, the vehicle intermittently will not start. So sometimes you go to try to turn the key and the vehicle will start. Sometimes you go to try to turn the key and the vehicle doesn't want to crank. So that's number one. Number two is that the key will not come out of the ignition. So the key is actually stuck inside of the ignition lock cylinder. Now, the third problem that the car is having is that the charging system is not charging. And finally, the fourth problem, they hooked up a scan tool, they ran a code check, and they found multiple codes across all of the modules for communication issues. So anyways, we're here today to check it out. Let's go ahead and get started. Okay guys, so a quick look under the hood. The first thing that I noticed, if you look down in here, you'll see the alternator. Looks like it's brand new. And if you look up here, you'll see the battery is actually brand new. So it turns out that the customer went ahead and replaced the alternator and the battery because they thought it was a charging system problem. Because like I said, the charging system is not charging the way it should. But even after replacing those two components, they were still having the same problem. Now you might notice that the engine is running right now. So the vehicle does start and run at the moment. Well, let me take you guys inside and show you the rest of it. Okay, so moving inside the vehicle, the first thing that I noticed, if you look down over here, you'll find the security light is illuminated. You'll also see a brake light and a traction control light that are on. Again, the engine is running at the moment, and I've actually got my scan tool connected. I already went ahead and I ran an auto scan, but before I get to that, let me show you guys the other problem that we're having. So this is the key in the ignition right now. I'm gonna go ahead and turn the key off. And as you can see, I cannot remove the key from the ignition switch. If I turn the key on, let me see if the vehicle will start. Okay, at the moment the vehicle is starting, but intermittently sometimes the vehicle will not crank, nothing happens. And as you can see, the security light is gone. It was on just a moment ago, so it looks like we have some intermittent problems kind of coming and going. So let me go ahead and grab the scan tool and show you what's going on. Okay, like I said, I went ahead and I ran an auto scan. Sorry about the glare on the screen. There's really not much I can do about it. But anyway, like I said, I ran an auto scan, and as you can see, we have multiple codes in pretty much all of the modules. Starting at the engine control module, we have 7 fault codes: TCM, ABS, supplemental restraint, instrument cluster. And you can see we have fault codes in all of these. So I'm going to go ahead and run a quick report. We can take a look at all of these codes. Starting at the top, we'll look at the engine control module. Looks like we have a few different communication codes. We have lost communication with the EBCM, which is the electronic brake control module. We have a code for lost communication with the climate control module. We have lost communication with the dash integration module. We have lost communication with the vehicle theft deterrent. Another theft deterrent. Fuel pump relay, system voltage. Then moving over to the transmission control module, we have wheel speed signal. And then looking at the ABS, we have class 2 data link malfunction. And then moving over to the SRS module, we have a code for a class 2 data link malfunction. Instrument panel cluster, we have a code for class 2 data link malfunction. And then moving over to the dash integration module, we have class 2 data link malfunction. We have a keep alive memory reset code. And moving over to the theft deterrent module, we have another class 2 data link malfunction and a few other codes. And then moving over to the vehicle communication interface module, class 2 data link malfunction. We got quite a few of these class 2 data link codes. Digital radio receiver, we have a class 2 data link. In the amplifier, we have class 2 data link malfunction. Man, bunch of communication codes here for the class 2 data link. Now looking at the climate control panel, class 2 data link malfunction. And driver door module, again, we have a class 2 data link malfunction. So it definitely looks like we have a problem with the class 2 data link bus system on this vehicle. There's no doubt about that, which would explain our various different problems, because the class 2 data link system on this vehicle ties together a lot of the different modules. Now, the other problem that I'm looking at is that when I got here, they had to jump start the vehicle to get it to turn on. So, I mean, because the battery voltage was really low, I'm pretty sure we set a few different codes just from the battery being low. So I think what I'm going to try to do real quick is I'm going to clear all of these codes and see which ones come back. So let me do a quick erase here. Let this thing erase all of the codes. Okay, so after clearing all of the codes, I went ahead and ran another auto scan just to see what were hard faults. So as you can see, we have, again, multiple codes. So I'm going to go ahead and run a report and see what these codes are. Again, we're going to be starting at the top with the engine control module. Right here. So we look here, we can see that we lost communication with the EBCM, lost communication with climate control panel, lost communication with vehicle theft deterrent, and then again in the transmission control we have a wheel speed signal, and again in the ABS we have class 2 data link. SRS we have class 2 data link. Instrument panel we have a class 2 data link. Dash integration module we have a class 2 data link. Digital radio receiver we have a class 2 data link malfunction. Amplifier, again, class 2 data link. Climate control panel, class 2 data link malfunction. In the driver door module, class 2 data link. Passenger door module, class 2 data link. And other door modules, again, the same thing, class 2 data links. In the memory seat module, rear integration module, we have class 2 data links. So it looks like all across the board, we pretty much have class 2 data link malfunction codes. And again, this class 2 data link system connects all of these modules together. So it looks to me like we're having a problem with these modules not being able to communicate with each other, or maybe not being able to communicate with the PCM in this case, because again, if we come back to the top, the PCM itself has multiple codes for different modules that are tied into the class 2 data link. Again, the EBCM, the climate control panel, the dash integration module, the vehicle theft deterrent. These are all class 2 data link modules. So it definitely looks to me like we have a problem there. I think first things first, let's go ahead and pull out the lab scope. Okay guys, so I have my lab scope connected. And what I have is this breakout box. As you can see, I have it connected to the data link connector here. And if you look over here, you can see the pinout that we have on this breakout box. And what I have are my 2 channels connected to pin number 6 on channel 1 and pin number 14 on channel 2. And the reason I picked pin number 6 and pin number 14 is because these 2 pins are for the CAN bus data lines, the high and the low. And then number 4 is going to be our ground. So this is how we have this thing connected. And if you look over at the lab scope, you can see that our signal actually looks pretty good. I mean, if you take a look at the overall signal, you'll see that they are mirroring each other. When one channel goes up, the other channel is going down. We don't seem to have any glitches or any dropouts. Our voltage on both channels seems to be at 2.5 volts, which sounds about right. So at the moment, I don't see anything wrong with the CAN bus data lines. Now, this vehicle is equipped with 2 different data bus systems. This is going to be the high-speed CAN data bus system on pins 6 and 14, but we also have the class 2 data bus line. Now this is going to be a separate data bus apart from the high-speed CAN data bus lines, and according to the scan tool, that seems to be where our problem is. Now this class 2 data bus link is only 1 wire, so unlike this high speed, we have a high and a low line. On the class 2, it's only going to be a 1 wire, so we're only going to be utilizing 1 channel, and we're going to be connecting it to pin 2. Okay, so now that I have my 1 channel connected to pin 2, which is the class 2 data bus line, we can take a look at the lab scope. Now, I've already adjusted my parameters here. We're only using 1 channel, and we're on a 20 volt scale on a 10 millisecond time base. And if you guys are familiar with the class 2 data bus systems on these GM vehicles, you'll know that what you should be seeing is a 7 volt to 0 volt square wave. So if you take a close look at this, you'll see that we have our 8 volt line right here, and this is pretty much exactly where we need it to be, 7 to 0 volts square wave. So we see good activity here. I don't see any problem with the signal, no glitches, no dropouts. It seems to me that everything is communicating on this line, and that actually makes sense, because if you think about it, guys, as far as the scan tool goes, we are actually able to communicate with all of the modules on the class 2 data bus line. Now think about that. If we had a module taking down the entire data bus line, we would not be able to communicate with any of the modules. But as you guys can see clear as day, we're able to communicate and extract fault codes from all of these modules. So we know that we do have communication on this data bus line with the scan tool. So hopefully that makes sense to you guys. Hopefully you're following along. Now the next thing we need to do is go ahead and move over to the wiring diagram and figure out our next step. Okay, so before we move to the wiring diagram, there is one thing I want to show you guys real quick. And I really don't know if there's any importance to this, but I found this really interesting. So I went to do a quick ohm check or resistance measurement on the high-speed data bus line. And if you guys are familiar with the CAN bus network system, you know that we have 220 ohm resistors in the circuit. And whenever you do a resistance check on the entire system, you'll know that we should be seeing about 60 ohms of resistance. So anyways, let me show you what I have here. I have the breakout box connected, and I have my leads connected to pin 6 and pin 14. This is set up as an ohm meter. So let me show you guys the meter right now. As you can see, we're reading 1.77 mega ohms of resistance. Now I saw that and I thought, you know, that can't be right. There's got to be something wrong with this. And then I went ahead and I switched these around. I mean, thinking it wouldn't make a difference because, you know, it's a ohm measurement. It shouldn't matter which way you take it. But I switched these around, and now take a look at the meter. It's showing 0 ohms of resistance, almost like there's some type of diode in the circuit. Now I'm not going to let this deter me because I'm not really sure if this is what I should be seeing on the system. I just know typically on most vehicles you should be able to take your own measurement right here at pin 6 and 14, but I have seen some vehicles that are set up a little bit differently, and I wonder if that's what's going on here. So again, I just wanted to put that out there. I'm not really sure if it means anything. I'm just going to take that with a grain of salt. Let's go ahead and move over to the wiring diagram. Okay guys, so we're here at the computer. I've got the wiring diagram pulled up for the computer data line circuit. Now we're going to do a basic overview of the system. We're going to see how it works. Then we're going to see if we can come up with any testing methods that we can take back to the vehicle to try to figure out what's going on. So let's go ahead and get started. Now, as you guys remember, at the beginning of the video, I did mention that we have 2 main data bus circuits on this vehicle. The first one is going to be your traditional high-speed CAN data bus lines. These are going to be found on the DLC connector pins number 6 and number 14. Again, these are the traditional CAN bus lines that you would find on most vehicles, in which we have a high and a low line. So I'm going to go ahead and zoom in on this wiring diagram, take you guys to the data link connector, which is located right over here. This is going to be our 16-pin data link connector. This is where we connect our scan tool. And if you guys look at pins number 6 and number 14, if you recall, this is where we connected our lab scope to pull up a waveform, and we noted that the waveform looked good. So if we follow this down, you'll see that pin 6 and 14 come over here, and you'll see it kind of split off over here. It's going to say if we have a 6.0 model, we're going to go this way, but if we don't have a 6.0, we're going to go down this way. And of course, this vehicle is not a 6.0, it's the V6 3.6 liter. So I'm going to go ahead and click on these two, highlight these 2 lines. We're going to follow them down, and you'll see that it goes to the transmission control module, TCM. So the interesting thing about this is that these 2 wires go into the TCM here, and they'll come out on these 2 pins here, pin 32 and 33. We're going to highlight those 2 pins, and if we follow them over, you'll see that those 2 pins, or those 2 wires, go to the ECM, which is the engine control module. Now, if you look at this circuit setup, that's pretty much it. That's all we have. It's going to be the TCM and the ECM. So as far as the high-speed data bus system, it really only involves 2 different modules. Now, if you guys recall, when we connected our lab scope to pin 6 and 14 on the data link connector, which is what we have highlighted here, we found that we had a normal waveform. We didn't see that we had any problems in that circuit. Now, the only other thing I wanted to address about this high-speed CAN data bus circuit is something that I found just out of curiosity. So if you guys recall, I connected my lab scope on pins number 6 and number 14 of the data link connector. And I did an overall resistance check, or a resistance measurement. And if you guys know anything about traditional CAN data bus circuits, you'll know that you should be able to do an overall resistance measurement on the circuit. And what you should find is somewhere around 60 ohms of resistance. And this is because in the circuit, you're going to have two terminating resistors. And each of those resistors is about 120 ohms of resistance. Of course, if you guys use Ohm's law, you'll know that those two resistors will divide each other out, and you should have about 60 ohms of resistance in the overall circuit. But if you guys remember, when I did the overall resistance check at the data link connector, we didn't find any resistance. Or in fact, what we found was if we connected it one way, we showed 0 ohms of resistance. And then if we flipped them over, we showed a different measurement. So that was kind of confusing to me. I kind of thought that there might have been a problem there, but let me explain to you why I'm not worried about that. So if we scroll back down to where these data lines connect to, again, the data lines come straight from the data link connector on pins number 6 and number 14, and we follow them down over here, and they go straight to the transmission control module on pins number 21 and 20, these two lines right here. Let me go ahead and deselect these so we don't get confused. Okay, again, so the two wires come from pins 6 and 14 of the data link connector. We follow them down. They go straight to the transmission control module on pins number 20 and pin number 21. And then what you'll see is that the two wires come out on pins number 32 and number 33. And then those two wires go over to the engine control module. Now, what happens here is these two lines are not directly connected to these two lines. There's something inside of this computer module that's happening where the information that's being transferred here is going through a processor, and then that information is getting spat back out on these two lines. Hopefully that makes sense, but what I'm trying to tell you guys is that these two lines are not a direct connection to these two lines. There is some type of bridge inside of this transmission control module that is processing or conditioning the signal that's happening here, and it's spitting it back out over here. So the information that we have here is not going to be the same information that we have going back and forth between the ECM. This right here is going to be for the purposes of the scan tool communicating with both of these modules. So it would make sense that if we did a resistance measurement on these two pins here, we would not be seeing the overall resistance measurement of the system here. Hopefully that makes sense to you guys. But what I'm saying is, on traditional systems, these two wires would be directly connected to these two wires, or there would be some type of splice in which all of these wires are connected together. So if you ask me, I'm pretty sure that if you go to the TCM, you will find the terminating resistor on pins 32 and 33, which are these two lines right here. That's going to be where you will find the 120 ohm terminating resistor that's built into the TCM. And likewise, if you go over to the ECM on pins 55 and 23, this is where you're going to find the terminating resistor for this one. So in order for us to do an overall resistance measurement, we would have to maybe tap into these two wires, or it might be easier to just go directly to the TCM or the ECM, do a pin out, and check the resistance across these two pins and these two pins here. So hopefully that makes sense to you guys, and hopefully you're following along. Let's go ahead and move back up to the data link connector. Let me deselect all of this here. Okay, so we'll move back up to the data link connector, and we are going to focus on the second data bus circuit that's on this vehicle. Again, like I said, there's two main data bus circuits. There's going to be the high speed, which is what we were looking at on pin 6 and number 14. But this time we're going to be looking at the second one, which is going to be the class 2 serial data bus line. And the interesting thing about this data bus circuit is that it's only one wire versus the high speed data bus line, which uses two wires. Again, pins number 6 and number 14 on the data link connector. It's going to be the high and the low line. This class 2 serial data line is only one wire on pin number 2 of the data link connector. Now this is going to be one wire because it's not going to be considered a high speed. This is going to be considered a low speed data bus system, and it's used mainly for accessories. So I'm going to go ahead and highlight pin number 2 on the data link connector. And if you guys recall, we had our lab scope connected here, and we found that we had a normal waveform pattern. And like I said, you should be seeing somewhere around 7 to 0 volt square wave, and that's exactly what we found. So we know that we should have good communication on this line, but we're still having a lot of communication codes. So anyways, let's go ahead and follow this pin number 2 from the data link connector. We follow it up here, you'll see that it goes off to a splice. Now this splice goes off into 3 other different areas. So again, if we follow it this way, you'll see that it goes to the theft deterrent module. Then if we follow it over this way here, let's follow it down, you'll see that it goes to the electronic brake control module. We come back up over here to the splice. We're going to highlight the last one, follow it down, and we'll see that it goes to the instrument panel cluster. So that's only a few places that you'll see that this data line connects to. So if you follow it out of the instrument panel, let's highlight this way, you'll see that that single wire goes into the instrument panel and it comes back out and it goes over to this junction right here. So again, we have another junction where this single wire splits off into several other different circuits or several other different wires. But even though this might look a little bit confusing, this is all just one wire. So it's not really that difficult to look at it, but if you follow along here, we can see what different modules are involved. Starting at the top, you'll see the driver door switch assembly. And again, the data bus line comes out of it and it goes over to the driver door module. And again, you'll see the data line comes out of that, goes over to the junction. Again, where this junction splits off. Let's just concentrate on the modules that are involved here. So you'll find the audio amplifier here. Then you'll find the left rear door module. Then you'll also find a memory seat module. Then you'll find here the inflatable restraint sensing and diagnostic module. Then if we scroll down, you'll find the digital radio receiver right here. Scroll down again, we find the radio antenna module. Down here, you'll see the rear integration module. Go down, we'll find the vehicle communication interface module. Again, moving further down, we'll find the front passenger door module and the right rear door module. Then down here we have the TV antenna. So as you can see, we have all of these modules here that are involved on this side of the diagram here, but you'll see that we have more modules over on this side. Looks like we have the dash integration module here, DIM, and then up here we have the radio. Then up here we have the HVAC control module. And then again, we have the instrument panel. So these are all the circuits, or excuse me, these are all the components that are involved in this class 2 serial data bus circuit. Now, again, like I said, this is all one wire, and this one wire is going to be how these modules communicate to each other. Now, the interesting thing is that, again, when we connect our scan tool to this on pin 2 right here at the data link connector, we find that we can communicate with all of these modules. Now, what I've seen before in the past, and this is coming from experience with these systems, is that you could have a bad module. Let's say you have a bad driver door module, and this driver door module is keeping the signal stuck high. This one module can cause this whole communication system to stop working. So from one bad module, it could take down this whole circuit. But typically when I see that, connecting the lab scope on pin number 2 and looking at the waveform can tell us that there's something wrong happening in the circuit. But again, as you guys recall, we connected our lab scope here and we found that we had a good 7 to 0 volt square wave. So again, we have communication with all of these modules. They're all talking to each other. But the one thing I found when looking at these trouble codes that we had in the computer is that they all seem to have a problem having communication with the ECM. So if you guys follow back over here to the ECM, which is the engine control module, you'll see that we have a class 2 serial data line connecting to the ECM. So what I want to do is I want to follow these class 2 data lines coming from the ECM and then try to figure out what could be going on here. So let me go ahead and deselect all of this again so we don't get confused. Okay, and we're just going to focus on the ECM here. Again, this is going to be our engine control module here. And if you guys focus up here, you'll see that we have a class 2 serial data line. And again, you'll see two lines here, but the important thing to remember is that we don't have a 6.0 liter. So if you follow this right here, there's going to be this kind of split off right here. It's saying that if we have a 6-liter engine, we'll have a line that connects from the EBCM over to the ECM. In this case, we don't have this 6-liter. We have the V6 3.6 liter, so that's going to be here, which says except 6 liters. So again, if you follow this one down, you'll see that the bridge comes out over here. I know that might be a little bit confusing, but essentially what I'm trying to tell you guys is that these two Class 2 serial lines are not applicable to this vehicle right here. So we're not going to worry about pins 16 and 15. We're going to focus on pin number 48. So if you look right here, you'll see pin number 48, Class 2 serial data line. This is going to be the only data line that goes to the ECM on this vehicle. So let's go ahead and follow this Class 2 data line or wire out of the computer. Again, it's coming out at pin 48. It's going to be this purple wire. So if we follow it out, you'll see that it goes off to a splice here, and then it splices off. So I'm going to go ahead and highlight both of these. Highlight it this way and highlight it this way. And I guess first we'll go up. So if we follow this up, again, we've already noted that it goes to the EBCM, which is the electronic brake control module. But if we follow it down here, you'll see that it splits off and it goes to the HVAC control module. Now, I don't know if I mentioned this to you guys, but the AC is not cooling on this vehicle. And of course, we have communication codes in the HVAC control module for communication between the HVAC control module and the ECM. So again, I'm just throwing that in there. That's something that we're going to look at. But of course, these lines, they split off again from the HVAC control module, goes over to the radio. Then from the radio, it goes over to the dash integration module. So you can see that if we had a problem or a break anywhere in one of these wires, we would not be able to communicate with the ECM, or the ECM itself would not be able to communicate with any of the modules that are on the Class 2 serial line. So let's say, for instance, we had a break in this wire here. So I'm going to go ahead and deselect it just to represent that we have a break in the circuit. We would not be able to communicate with the ECM, nor would the ECM be able to communicate with anything on the Class 2 serial data bus circuit. Likewise, if we had a problem or a break in this splice here where we lost communication between the EBCM and the HVAC control module, then we would know that it's likely that we have a problem in the splice here. But I can tell you right now, it seems that we have communication with all of these modules. So I went through with the scan tool and I can connect to all of these modules. So I know that there's not a problem in the Class 2 data bus circuit. This is kind of leading me to believe that we may have a problem with the ECM, because again, it seems that everything on this Class 2 data bus circuit can communicate with each other, but none of it can communicate with the ECM. So in my mind, I would say that there's a good chance that we have a problem internal to the ECM. Now, how do we prove this? I think there's a few different things that we can check. Number one, we could go to the computer, make sure we have good powers and grounds, which is something we probably should do anyway. Number two, we could probably go to this pin number 48 here and do a continuity check between pin number 48 here and, let's say, anything else in this circuit. Let's say, for instance, the instrument panel, or maybe even the HVAC control module. That would probably be an easier one to get to. So let me deselect this just so I can explain this a little bit better. So we know that we have a direct tie between pin 48 at the computer and pin 9 on the HVAC control module. So if I were to take an ohm meter, connect it to pin 48 here at this connector, and then connect the other end at pin 9 of this HVAC control module connector, we should have good continuity between these 2 points. That check there will tell us whether or not we have a break in the wire somewhere between the ECM and the rest of the system. So that's one of the checks that we can do. Another one that we can probably do is go back to the ECM and maybe even check the terminating resistors here at the ECM and at the TCM. I think even though these two lines are not directly connected to the Class 2 serial data line, it's probably a good rule of thumb to just check the terminating resistors that are in here. I mean, because there could be some internal connection that we're not aware of. So again, if we don't find anything else, I mean, this is probably something that we could check too. It's easy enough to do, and actually the ECM and the TCM are actually both pretty easy to get to. So if you look at the ECM, it says that it's on the right valve cover. It's right on front of the valve cover, and then the TCM is at the right front of the engine compartment. So these are both actually really easy to get to. I think that's probably the first thing I'm going to do. So I'm going to go ahead and locate the ECM and the TCM. We're going to check the terminating resistors here on pin 55 and 23 on the ECM, and then on the TCM we're going to check it on pins 33 and 32. We should have 120 ohms of resistance here, and we should have 120 ohms of resistance here. So let's do that. Then we'll probably do a continuity check on this class 2 serial data line, and if everything here checks out good, then we'll move on to checking the main powers and grounds, and quite possibly call this a bad ECM. So again, this is just theory. We need to do some testing. So let's go ahead and move over to the vehicle and do our checks. Okay guys, so we're here at the computer. Luckily, the engine computer is really easy to get to. It's right here on front of the engine. And as you can see, I already went ahead and disconnected the connector here, which is a C2 connector. And I also went ahead and located the 2 pins, which are going to be pin number 23 and pin number 55 on the connector. Now we're going to be doing a resistance measurement on the actual pins. So if you look here, I have my little female pin terminals connected to the 2 pins at number 23 and number 55. And as you can see, I have it connected directly to my meter here, and we are set up to read ohms. And if you look at the meter, we're showing about 114 ohms of resistance directly at the computer. And again, I know the specification is 120 ohms. This is a little bit off, so I don't think that that's really a problem. It's pretty close to the specified resistance, so I don't think that's going to be a problem. Now, the next thing I think I want to do is do the same resistance check at the TCM, which is located right over here. Again, it's actually pretty easy to get to. I think we can just pop this connector off and pull this TCM out and do our measurement. Okay, so as you can see, I went ahead and I pulled the TCM out, and I already went ahead and located the 2 pins that we're going to do an ohm measurement on. So we're going to start by doing pins 20 and 21, which, as you can see, I'm tapped into pin 20 and 21. And if you look over at the ohm meter, you'll see we have 120 ohms of resistance, which is right on specification. So now I'm going to go ahead and move these over to 32 and 33, which are just right underneath it. We're going to do a resistance measurement on these right there. Now take a look at the ohm meter. We're showing 120 ohms of resistance. So it looks like the terminating resistor inside of the TCM is good. I'm gonna go ahead and reinstall this, and let's move on to the next step. All right guys, so we're back at the vehicle. Let me show you the setup that I have now. So as you can see, at the C2 connector, at the PCM, I have my back probe on pin number 48, which is this purple wire here. Again, this line is for the class 2 serial data bus line. And on the other end, I have my lead connected to the back of the HVAC control unit. So you can see right here, I am back probed on pin number 9, which is the purple wire. And what I'm doing is a resistance measurement between the HVAC control unit and the ECM. So let me take you back under the hood and let's check out our reading on the meter here. Sorry about the glare, but if you can see here, we're showing about 0.90 ohms of resistance, so less than 1 ohm of resistance. Now, I would expect to see 0, but to be honest with you, I'm using some really long leads. So if you look here, I have this 15-foot retractable test leads, and so that's about 15 feet of wire, including the wiring there. And I mean, I may not have the best connection here, but we kind of wiggle this around and you see it drop a little bit. But anyway, our resistance measurement looks pretty good. Now, as far as the splice, we know that it's somewhere in the wiring harness alongside here behind the transmission connector, somewhere down here. So I guess if we're worried about a problem there, I'm going to just move the wiring around like this, and I'm going to watch the measurement on the meter we're going to see if we have any changes. Again, I'm just kind of going through the entire harness here, moving it around. And I don't see any change in the reading there. So it looks to me like we don't have a wiring problem. Our continuity between the ECM and the HVAC control unit inside is good, but our HVAC unit and our ECM are not communicating with each other. Again, guys, I'm lining up the dots here. So we can communicate with the HVAC control unit with the scan tool. So we know that the class 2 serial data line is not completely down. We can communicate with the ECM using the scan tool, but those two units are not talking to each other. So I hope you're following along here with my thought process, but to me, it seems like we have a problem with this engine computer. So at this point, I think my next check is going to be checking for the main powers and grounds to the computer, making sure that everything is there that needs to be there. And if everything checks out, then this thing's gonna need a new engine computer. Okay guys, so let me apologize for skipping this step. The shop was really pushing me to give them an answer as far as whether or not they needed to order the engine computer. It's getting late in the day, so they wanted to make sure we could still get it. And plus the customer was calling them nonstop today trying to figure out what's wrong with their vehicle. So anyways, I went ahead and I checked the main powers and grounds. It's pretty simple to do. We have everything there. Our ignition voltage feeds are there. Our battery voltage feed is there. And of course our ground. Now, like I said, the ground on this engine computer is actually ground to the body of the computer. So if you look at this computer, it's actually bolted to this bracket, and this bracket is bolted to the cylinder head. And then they even put an extra ground strap here that goes alongside the block over here. So I went ahead and I checked those two grounds. Everything looks good. I feel pretty confident that this thing needs an engine computer. So they're gonna go ahead and order one and get it on the way. All right guys, so we are back here to give you the update on what's going on with the vehicle so far. This is actually 4 days later. Let me explain to you what happened. So if you look up here, I got my laptop and I use the J-Box to program the replacement computer. Let me take you under the hood. I'll show you the replacement computer. Right over here, already installed and programmed. Let me take you inside and show you guys that everything is working now. So let me just move this inside. All right, so first things first, the engine is running. We have no check engine light. We don't have any service lights or indicators on right now. And the AC is blowing nice and cold. Before the AC was not working. Now the AC is working just great. And the big thing is now we can take the key out and put the key back in and start the vehicle up, and it starts every time. And we no longer have our security light staying on. You can see it just went away. So everything's good. Let me take you over to the scan tool and show you guys. Let's put it up here. I already went ahead and ran an auto scan on all of the modules, and as you can see, we have no fault codes in any of the modules. Well, we have a couple of fault codes with the amplifiers, but we're not going to worry about that because this thing does have an aftermarket radio in it. So that's probably why we're seeing these fault codes. They're not affecting anything else. So like I said, we're not going to worry about that. Now, let me explain to you guys why this is 4 days later. And well, let me roll the windows up here so no one thinks I'm crazy talking to myself inside the car. Anyways, guys, so this is my 4th day back here. And the reason being is because we actually had to put 4 different computers in this car before we got a good computer. Now, let me explain to you what happened. First, they ordered a remanufactured replacement computer from a company here in Houston called NPC. And I'll tell you right now, guys, I've never really had good luck with them. It didn't surprise me that the first computer they sent me from NPC, which of course is a remanufactured one, didn't work. So I put it in the vehicle, it was programmed, and everything was working fine. We had communication on all of the modules on the class 2 serial data bus line. So I know replacing the computer was the fix for that communication problem. Now, the only problem that that computer had that they sent us is that whenever I would go to start the vehicle, it wouldn't crank. And when I looked for trouble codes in the scan tool, in the ECM, we had a trouble code I believe it was a P1605, and it said something about the starter relay control circuit. And so I had to do another diagnostic checking the starter relay control circuit and everything involved with the starter, and I found that we had no problem with the starter relay circuit. The control voltage was reaching the computer, but the computer just was not grounding the starter control relay. So naturally, I had them send it back, and they sent us a replacement computer. I came back the following day to install the computer and program it, and believe it or not, the second computer that they sent us had the same problem that the original computer in the vehicle had, which was the problem where it was not communicating with any of the modules on the class 2 data bus line. And at that point, I was really frustrated because I had to go over everything in the vehicle again just to make sure that I wasn't incorrect with my diagnosis, because I thought, how likely is it that we receive another computer that has the same problem that the original computer did? So anyways, after checking everything over again, I came to the conclusion that the second computer they sent us was bad. And so at that point, the shop manager was pretty frustrated. He said, you know what, forget about buying a remanufactured computer from MPC. We're gonna buy a computer from the dealer. And so he goes ahead and orders a computer from the dealership. I come back the following day to install the computer and program it. Guys, you won't believe it, but this computer that we got from the dealership would not communicate at all with my scan tool or with my laptop. The computer was just completely dead. Now, I will say that I was pretty suspicious about the computer that we received from the dealership because the package was open and it looked like somebody had already installed the computer, because the computer is held on by 4 screws, and you can see that somebody had installed the computer and tightened down the bolts, because the bolts left the little scuff marks around the bolt holes. So I knew the computer had been installed and returned to the dealership by somebody else. And so at this point, I'm trying to explain to the shop manager what's going on, and he's starting to get kind of frustrated. And I'm not saying that he didn't believe what I was telling him. And I was starting to get the feeling that, this really wasn't making me look good. It was kind of making me look like I really didn't know what I was talking about or what I was doing. So I really had to convince the shop manager, look, man, I'm telling you, this computer that you got from the dealership does not want to communicate. It's a complete dud. You need to send this one back and have them send you a replacement one, and make sure that that one comes sealed in the package and hadn't been installed by anyone previously. So anyways, he goes ahead and orders another one. It just got here today, and so I'm back. This is the 4th day. This is the 4th computer. I just installed it. I was able to program it. I can communicate with it fine. After programming it, everything is working good. Anyways, guys, I'm gonna go ahead and end off the video. Like I always say, I hope you enjoyed it. I hope you found it useful. I hope you found it informational. If you did, make sure to give it a thumbs up. If you haven't done so already, make sure you subscribe to the channel, hit that notification bell, and I'll see you guys in the next one. Thanks.